why my antivirus evasion tool sucks. Let's talk about it. But first, a little bit of context. Before doing Tyler's box on Try Hack Me, Hack Smarter Security, I already had a few custom evasion tools. But the privilege escalation method on Hack Smarter Security required a Windows service binary, and none of my tools at the time made a Windows service binary. That's problematic. Instead of writing a simple Windows service binary to finish Hack Smarter Security, I spent 3 months of additional work to build another custom evasion tool. Codename Byte Me Builder. Okay, this name honestly sounded better in my head. Byte Me Builder was originally made for CTFs to bypass Windows Defender, and it works, but not without its issues. Before jumping into the issues, first showing the basics of Byte Me Builder. There's a bash script to help automate some of the obfuscation methods for different types of payloads. To start, we'll create some basic shellcode with MSF Venom that we'll use as a proof of concept for getting past Defender. Since Metasploit's shellcode is highly signature, format raw -o msf.bin. Now that our shellcode has been created, we will use Byte Me Builder with mixin1 and our weapon file msf.bin with raw format because we created a raw binary file, and then our runner 4. Using mixin1 to obfuscate the shellcode without using traditional encryption isn't enough for mixin1, which I will demonstrate, and the default file name is Cocoon. So I'm going to netcat lvmp and python-m on port 80. Going to our Windows machine, cmd.exe, we'll grab Cocoon, and when we try to grab it, Windows Defender gets alerted because it's not enough. Going back to the terminal, minus all my crazy requests, arrow back up, and we're going to add an encoder to our shellcode runner and payload for the simple reverse shell. Listen again. Come back here. Show that Windows Defender is active. And when we grab this file, it doesn't get flagged by Defender. We'll just go back into our terminal, use netcat mvop 1212, listen again, show that our file is in this directory, run Cocoon, and we get a reverse shell. Exiting out of this reverse shell, moving on to the other element of Byte Me Builder, which is basic payloads. In this case, we're going to create a DLL payload that just does a basic reverse shell. So Byte Me Builder, D for DLL payloads, and like Metasploit, we can add the interface name for the IP address. So ETH0, it will be that, and then our port will be 8443, and then we'll just call this basic.dll or base.dll. That's fine. We have our file, base.dll, which is cross-compiled as a DLL. Listen again, but this time on 8443. Go back into Windows, and we'll grab our base.dll payload. Windows Defender has not flagged on anything. There's no alerts. We still have our file in this directory. Now to execute our DLL, we can use run dll32.exe or regserve 32.exe, and then our base DLL. Execute this. Windows Defender does not flag on anything, and we get a shell. That's the basic use of Byte Me Builder. Moving right along into the issues section of the video for Byte Me Builder, our first issue, which is over time, some of the techniques in your tool will get flagged by Windows Defender or another security solution. So like before, we'll create our shellcode and use our first shellcode runner in the tool that is signature by Windows Defender to prove that it's just flagging on the shellcode runner itself for that payload. I'm going to encode it. So Byte Me Builder, format raw, like before, weapon file, again, msf.bin, doing runner 1, output as 1.exe for our first issue, and then adding -e, our encoder that was shown in the demonstration of how Byte Me Builder works, to prove that it's flagging on the runner itself, not our shellcode. We have our 1.exe, which is a C# payload. Going back to our Windows machine, we will grab one.exe, and immediately it will be flagged by Windows Defender. To get a little bit more information, I'm going to turn off Windows Defender and run threat check on one.exe. And we can see that this part of the shellcode runner is getting caught. If we go back to our terminal and use Byte Me Builder with the -k flag, it will save all the files that it uses. We can look at our shellcode runner, C# run.cs, and even though that our shellcode is encoded because it doesn't start with the traditional like FC, 4A, etc., it's still getting flagged and terminated by Windows Defender. The second issue with Byte Me Builder is that with our encoder, some of our payload and or shellcode runners are not compatible with our encoders. Using, again, the msf.bin file, I will create two different payloads, one that is compatible with the encoders and one that is not. So like before, msf.bin, our second shellcode runner will work, so we'll just call it work.exe, and then we'll do encoder 1. The next shellcode runner 3, is incompatible with the encoders, so when we scan it or upload it to the box, it won't be malicious because it doesn't work. So fail.exe, encoder 1. We have both our files, work and fail.exe. Make sure we listen. Alright, use 1212. Yep. Listen again. Going back to the Windows machine and using our little download script to grab work.exe and fail.exe to this machine. Now if I run threat check again on work.exe, no threat is found. If I do it on fail.exe, no threat is found. If I try to run fail.exe, nothing happens, and we get no shell within our Kali machine. But if I run work.exe, it hangs, and we get a reverse shell. The third issue with Byte Me Builder is that when using an encoder or mixin option to obfuscate a large shellcode payload, what ends up happening is either it takes a long time to compile or just fails completely. Luckily, MSF Venom shellcode is just small enough to fit for their unstaged payloads. So I'm just gonna grab this instead of having to retype it all over again to make our raw shellcode. And then Byte Me Builder, our weapon file, format raw, runner 2 with encoder 1, we'll output it as encoder.exe to simulate our encoded payload. We get all these errors. However, encoded.exe is still created. To simulate our mixin payloads, we'll just do mixin 2 with runner 1. Format raw like before, weapon file, msf.bin, and we'll output as mixer.exe. Alright, we have both our payloads. Now to Python 3 and grab our files on Windows. cmd.exe, download encode.exe, and we'll grab mixer.exe. Going back into our terminal, we can see I already have the multi-handler set up with our unstaged payload, and we have exit on session set to false, so I don't have to restart the listener every single time. Now if I run encode with Defender enabled, we get an interpreter session. Let us create a new cmd prompt and run the other one, which is mixer.exe. we get a second interpreter session. If I do sessions 1, it still works. We can do sessions 2, and it works. Killing all of our sessions real quick so we can move forward in the demo to how the encoder works. Going into this directory, and we can see we have a bash script for the encoder. In this case, it's just a XOR encoder. We'll just do less on dual XOR encoder. And basically, we take our shellcode, we read it. It's originally in PowerShell format. It gets converted into this format without the commas. And then the iRead team proof of concept, where we have the XOR logic in bash instead of PowerShell. I'll post a link for that in the description. And then once we have our encoded shellcode, I will pass it into this assembly file with the way to decode it. You're going to jump to the decoder stub, store our encoded shellcode. Once our assembly file has been created, we'll use NASM to compile our assembly into a coff object. Next, we'll use the ld command to take our coff object and compile it as an exe. Now that is a compiled executable with our payload. However, because there's no logic in how to execute it, we need to first extract all the hexadecimal bytes with object dump in this for loop. And because we're using a C# runner, we need to reformat it into C# or PowerShell format. Once I do that, it will be passed into this end-of-line file cat, and we'll put our shellcode into our runner, put it into a file by redirecting it, and then mono-CSC compiling it into an executable. Unfortunately, this one is not compatible with a large payload, so I will have to use a simple reverse shell. With format PowerShell, of course, instead of format raw like I've been using previously in the video. Original shellcode.txt. The next step is to nano the original shellcode and cut off this byte buff equals. Alright, and then go back, run dual encoder. We get this error, but that's not really a big deal. We still have our file. Listen here, and we'll just do netcat over here. Go back to our Windows machine. Grab our 2rthread.exe. Run it, and as we can see, Windows Defender doesn't catch it, and we have a shell. The main problem that pertains to issue 3 is that when using shellcode from other frameworks, such as Sliver, which are Go based, have much larger payloads than what Byte Me Builder can support. So to demonstrate that, we'll just create a simple mtls payload, generate and then format shellcode. Alright, now that we have our shellcode, we'll go into this directory again, and then move our shellcode to this directory. Do Byte Me Builder, mixin 2, runner 1, weapon file French, go.bin, format raw, and then output to sliv.exe. While this is running, it will just take forever, and if it doesn't work, it will just crash out with an error. Instead of waiting here all day, I'm going to just Control-C out of this command and propose a different solution, which is remotely hosting our shellcode on our attacker machine and then grabbing it with our shellcode runner of choice. In this case, I will demonstrate our solution that's already built into the tool that allows us to do it over a secure SMB share and a web server. So first, Byte Me Builder, runner 2, mixin 4, our URL parameter. I'm just gonna grab this from my notes so I don't mess it up. This one is going to be our password protected SMB share, and then our shellcode. smb load.exe. Also, when it runs, it gives us the packet command, which is very nice. We'll run that right there. And then we'll do Byte Me Builder runner1 mixin for our URL payload. And we'll call it http load.exe. We will start our Python web server alongside our SMB one. Going to our Windows machine, we'll grab SMB load and http load.exe. Windows Defender is still active and has not caught our payloads. When I run http load, we get download successful. It requests our shellcode, and if we go back to sliver, we have a session. We can do use and then our session ID, and then do like who am I, and it works. Background. Going back to our SMB and HTTP servers, put that to the side. Get a new CMD prompt. Make it a little bit bigger this time. CD to demo evasion. If we do SMB load, run it, we can see that there has been an SMB request. Go back into sliver, we have another sliver session. Use 5 it, which is our other sliver session. And that concludes my thoughts on Byte Me Builder and the state it's currently in. After everything's said about Byte Me Builder and its issues, how do I plan to improve the tool beyond the basics of removing what doesn't work and lowering obfuscation time for large shellcode payloads? First, I'm going to split the tool into 2 different tools. One with the original name, Byte Me Builder, which is going to handle all the basic payloads on top of including additional payloads for web shells, and other quick things, putting all the shellcode-based runners and shellcode-based payloads into a new tool called interim obfuscator with additional encoders and additional mixins to help speed up obfuscation, with the same idea as Byte Me Builder to include web payloads. And on top of that, additional feature will add custom C2 stagers for certain frameworks like Sliver. And that's about it. Hopefully it doesn't take me too long to make the tool like the last one. Who knows? Thanks again for watching if you made it this far, and I'll see you all in the next one. Take care.